We can place a series of mirrors and lenses near each other to create a series of optical events. In this case, we start with one object and we work iteratively through each optical element we have to create a final image. Along the way, the image created by the first optical element will be used as the object for the next optical element. So let's see an example of how this works. Here, I have two converging lenses spaced as shown. If I have an object at some distance DO from the first lens, I can use my ray diagram to show where its image will be, here, shown in blue. Now I could also use the lens equation to figure out the exact numbers, which we'll point out later. Now that image will now be used as an object for this lens too. So keeping with our convention, that blue image from lens 1 is now the red object for lens 2. Now I can again do a ray diagram and trace it out to find the final image created by lens 2. Now we can do this all very exactly using our lens equation. For the first lens, we take into account its focal length, the distance of the original object to the lens itself, and the distance of the image from that lens. Now that will place us at some distance here. And that distance, based on the distance between the lenses, will allow us to figure out what our new DO is for lens 2. Based on the new DO for lens 2 and the focal length of lens 2, we can calculate what DI2 will be. Now the magnification for a series of optical elements is just the product of each individual magnification. So I can just multiply M1, M2, M3 all the way down. So in this case, I take the magnification from lens 1 and multiply it by the magnification of lens 2. Here you see the negative signs canceled, which is why we started with an upright image and ended up with another upright image.